Hey everyone, we're going to take a look at number 10 in section 3.6. We're going to find or an equation of the tangent line at x equals 0 for this function here, y equals x to the 12th plus cosine of x. Again, your function could be slightly different than this one. So how do we proceed? How do I find the equation of a tangent line? Well, for an equation of any line, you need ideally the slope and a point on the line. I can easily find the point of tangency because it's when x is 0, so I just plug in to get the value of y. But what about the slope of the line? Well, remember the slope is what the derivative gives us. And so we need to find the derivative of this function. And that's pretty easy to do, right? What is the derivative of x to the 12th plus cosine of x? Well, the derivative is by the sum rule. I take the derivative of x to the 12th by the power rule, 12x to the 11th, right? Subtract 1 from the exponent. And then plus the derivative of cosine of x. And you need to know from this section that we're in 3.6 that the derivative of cosine of x is negative sine of x. So plus a negative, just I can write as minus sine of x. So here's my derivative, pretty easy. And now what's my slope? It's this derivative evaluated at 0. Well, notice what happens when I plug in 0 for x. Recall that sine of 0 is equal to 0. And so this, right, is 0 minus 0, which is 0. So our slope is 0. What's that mean? Think about that. What about our point? As I said, the point is 0 comma y of 0. And so I can just go back to the original function here and let x be 0. This time, notice cosine 0 is equal to 1. And you should be able to get this information. You will have the unit circle. Make sure you know how to know the exact value of sine and cosine. Obviously, we want exact values here. But at any rate, we get 0 plus 1, which is 1. Now, what kind of line do we have here? If our slope is 0 and our point is 0 comma 1, which would be what? The y-intercept. Well, we have a horizontal line. So if we go to our y equals mx plus b, of course, m is 0, as we said here, and the b, this is the y coordinate of the y-intercept in this formula, right, is 1. You just get literally y equals 1, right? If the slope is 0, that means you have a horizontal line. And just as a check, we can confirm this information. Y equal 1 is our tangent line, and the original function is x to the 12th plus cosine of x. And so I have that entered into the calculator here. And if we just make sure that indeed, since we're dealing with the trig function cosine of x, that you're in radian mode, that's real important. And then I'm going to open up a window that looks like this. I've played around with a little bit. Sometimes it takes a little bit of finagling to make sure you see where that is. Make sure you've got the point that's on a point of tangency, and you want to be able to see that the line indeed looks tangent. Sometimes that's hard to do, but this one comes out pretty easy. Here's the graph of this x to the 12th plus cosine x function. It kind of looks like x to the 12th with a little wiggle in there from the cosine function, if you will. But you can see right there at 0, comma 1, that point of tangency, it certainly, here's the red line, which is y equal 1, that horizontal tangent line. It certainly looks tangent to the graph at that point. You can also check with Desmos or something like that graphically to check, but hopefully this is helpful on this one.